Hello, I'm Colonel Philip Blair, MD, and I want to talk to you about biohacking the metabolism and your health with beta-caryophyllene. It's a fantastic substance that has a huge potential for many different diseases and conditions. Let me tell you a little bit about myself. I went to United States Military Academy at West Point in 1972. I spent 26 years in the service. I retired in 1997 with a tour at the first Gulf War in 1991, where I was a combat medic there, a combat physician in that role. I also worked with employee health and disease management firms. And then in 2014, I joined up with a major CBD business and operation, and I learned my ropes and learned the techniques and the science of cannabidiol on the body. And about 2 years ago, I learned about beta-caryophyllene and discovered the high potency and the high effectiveness with this substance not coming actually from hemp. And it's individually derived, and it doesn't have to be a source from hemp. So what is beta-caryophyllene? It's an essential oil. It's common in many spices that alleviates pain, inflammation, anxiety, and metabolic disorders. It's found in thousands of plants, but it has high concentration, about 36 species, including hemp. It's FDA approved as a food flavoring. Not only is it FDA approved and considered generally regarded as safe, it's also European Food Safety Authority approved as well, whereas CBD is not approved and is currently facing legal implications with the use of the CBD and hemp products. Well, it was first synthesized in 1964, and it was identified as a particularly strong CB2 receptor agonist on the endocannabinoid system. It's got very favorable brain penetration, and it's FDA approved. I said that before, and it's got great bioavailability. It's got excellent pharmacopeutics, and it's got very low toxicity. There have been about 3,300 studies in PubMed discussing beta-caryophyllene and its particular benefits in the body. With regard to safety, a lethal dose requires a huge amount of this substance, and it's not practical to give rats in this range. But there's been no toxicity that has been elaborated on in any studies that I'm aware of. It's safe for lung exposure, for skin exposure. It doesn't produce any abnormal behaviors. It doesn't produce any histological changes in the cells, nor tumors. And this is an important point, is that it doesn't offer, there are no reproductive effects on conception, gestation, or ovulation. It's an anti-mutagen against preventing DNA damage by mutagens. It's amazing in this capacity. And then with regard to metabolism, it undergoes metabolism and it inhibits metabolism through the CYP3 450 system 3A4, which is a non-competitive inhibition, which actually means that it does not interfere with any drug metabolism to date that I've recognized. So there are only 10 human studies on this incredible substance, and they're all positive, and they haven't included any large number and large clinical trials. And it's unfathomable why they haven't. Each of these studies recommends it for further study, but these studies have not taken place. So beta-caryophyllene works mainly through this endocannabinoid system, but it doesn't come from hemp. What is the endocannabinoid system? It plays a critical role in our survival due to its ability to maintain homeostasis and balance in the human body. Whereas dysfunction of this particular system is associated with many diseases. It's associated with migraine, metabolic, obesity, neurodegenerative conditions like Alzheimer's and Parkinson's. They all have a relationship to this factor that could be instrumental in correcting. So what I would like to do today is talk to you about beta-caryophyllene as an alternative solution for wellness, because many people face limitations due to legal or personal constraints with regard to hemp and cannabis use. And we've discovered that there's a need for non-cannabis or hemp alternatives. So the existing market options might not be adequate to cater to the current pain points, the needs or the preferences of many individuals, especially for our first responders. So there are legal constraints, there's concerns about the psychoactive effects, and there's limitations on the availability of effective, safe, and legal substances in the individual states. Whereas beta-caryophyllene appears to meet this broad spectrum demand without any adverse effects or career risk. Benefits include pain management, stress relief, improved sleep, enhanced overall wellness without compromising mental clarity. So the endocannabinoid system can be thought of as the 12th body system within our body, and it is a master regulator of all the other systems. If you look into detail, all these other systems coordinate through this master regulator, the endocannabinoid system, in many ways. And dysfunction leads to these different illnesses that we will describe in the next slide. But the master regulator controls cognition and memory. It controls cardiovascular health, hormones, metabolism, reproductive health, digestion, muscle and bone resilience, inflammation, mood regulation, energy, and cellular maintenance. And those all translate to a number of symptoms that we encounter with pain, mood, appetite, energy, sensation, metabolism, inflammation, stress response, and even eye pressure can come under the category of the endocannabinoid system, and the benefits or the dysfunction into the disease states that we can encounter. So what is exactly the components of the endocannabinoid system? First of all, it consists of a number of receptors that identify with this particular system and ligands or connecting molecules that actually activate or inhibit these particular receptors. It's composed of the enzymes that either synthesize and degrade these molecules that are involved, and it actually includes transport proteins that are invested in this particular system. So you can see that it's a complex and pretty much under the wire system. We haven't got adequate tests for measuring these particular substances, not in the public domain, so that they're not being tested and they're not being evaluated. And plus, the cannabis stigma has limited research into this general area. Well, first, I want to talk about CBD and beta-caryophyllene as a comparison, because CBD is a very popular and widely studied hemp and cannabis-derived substance, but beta-caryophyllene is also widely studied in a preclinical stage, but it differs in that it doesn't come from hemp or cannabis sources at all. So I want to talk to you about comparing and contrast, how they can be used together, what is beta-caryophyllene exactly, and the safety and dosing of these particular substances. So this slide compares the beta-caryophyllene to CBD. On the left side, you've got CBD as an enhancer. It treats anxiety, mood, Parkinson's, brain injury, wound healing, but it does have some negatives in terms of anxiety. There are high interactions. There's a drowsiness that can occur, and there's dryness and increased eye pressure that actually happen. On the right side, you see beta-caryophyllene is also a ECS or an endocannabinoid enhancer, but it actually affects on neuropathy, vision, depression, GI symptoms, allergy at the mast cell, weight loss, diabetes and cholesterol, addiction, and libido. And the only negatives are really the taste and the mild headache that is temporary. But when you put these substances together, you get a tremendous synergy with regard to pain, to sleep, to inflammation, to epilepsy, to autism, and to dementia and cancer. And so in many cases, you may want to combine these, but they work alone as well. And I have evidence to show you in that regard. Now, this was a study that looked at the entourage effect of full spectrum cannabis. And their conclusions were that in cannabis science, cannabinoids, terpenes, and flavonoids have often been overlooked, but much of the literature focusing on predominantly the major cannabinoids of THC and CBD. However, we've got to get shifted. These studies have to get shifted over to terpenes as well. In fact, the beta-caryophyllene is the most highly represented and promising terpene in the medical and the therapeutic research and regarding the endocannabinoid system. So this is a particular study where evaluated for pain in beta-caryophyllene and cannabidiol. And at the top, you see CBD compared with a pain, a graph of the rats who were measured on the pain receptors. And they found that they had a good relief at 2 milligrams per kilogram, whereas in beta-caryophyllene was relief at 2.2 milligrams per kilogram. But when they combined the two, they had dosage reduction and they had elaboration of the pain relief. So combined, independently, they worked very good together, but combined, they actually had a synergy, and it was a striking synergy. Now, on the left, I compare some of the pathways that are involved with beta-caryophyllene and CBD, and they're very subtle changes, but they work on the same general pathways, except that CBD is a weak CB2 receptor agonist, whereas beta-caryophyllene or BCP is a very strong activator and the primary mechanism of action of this molecule. So what happens with THC? It turns out that beta-caryophyllene can actually enhance the THC effects when it's taken in, when THC is used in large doses. And because and we're not sure why this is happening. It could be that the THC gets absorbed into the fat cells and beta-caryophyllene stimulates the release of fat cells, the lipolysis of fat cells, so fat release from fat cells, and it could release THC. It could be the enzymes that degrade the endocannabinoid system, but this is unlikely because they don't actually have any effect on THC. And there could be some connection with the CB1 receptors in terms of a heteromere or a combined relationship with CB2 and CB1 in a combination. And finally, there's a CYP450 system, but that's unlikely because THC doesn't actually get metabolized by this connection. Now, I say this, but I actually have reports that combining THC, if you get a high, you can actually alleviate yourself from the high by using beta-caryophyllene at the later stages. So there's a definitely benefit for using it. And I also point out that there are a lot of THC food enhancers that are talked about in the general lay literature with mango, broccoli, avocado, and grapefruit. If you use those foods when you take your THC, you're going to get a higher high, is talked about. Well, those foods all contain significant amounts of beta-caryophyllene. So that's consistent with our finding and the case studies that we found with THC and beta-caryophyllene combining as well. And I've got a couple of testimonials that really speak to this strongly, where people have found that the benefits of using THC have gone down significantly by using beta-caryophyllene, and they've gotten better pain relief with the products as well. So let's talk about beta-caryophyllene as a natural endocannabinoid activator with no adverse effects. This is amazing, this property of this molecule. But first off, it is a dietary cannabinoid. So it's found in a number of different foods and herbs, and it's even found in cow's milk from pasture-raised animals. And now the Mediterranean diet is a particular model of a healthy diet. And the reason that this is healthy is because it's loaded with endocannabinoid modulators and substances that can rectify or correct for endocannabinoid deficiency syndromes. And the key factor in most of these molecules is, in fact, the CB2 factor, which is going to be beta-caryophyllene. So it's found in a number of foods. And beta-caryophyllene actually works as a fatty acid amide hydrolase inhibition, which actually prevents the degradation of endocannabinoids and raises the levels of those endocannabinoids. And so you're going to get an enhancement of the effects and the benefits and a greater regulation of your endocannabinoid system. Plus, it also interacts with the GPR55 and the TRPV1 receptors that control pain and inflammation. And so you've got all of these mechanisms, this particular slide targets beta-caryophyllene in particular, but they talk about it as a Mediterranean diet and in general for all of the benefits of this particular diet. So let's go on to inflammaging as an immune metabolic viewpoint for age-related diseases. So I'm going to talk about beta-caryophyllene and inflammation pathways, biomarkers, cellular reproduction, and mast cell activation syndrome that I think is going to be exemplary in this process. So first off, how does beta-caryophyllene work? Well, it's got over 100 targets of engagement, and that includes different specific receptors and signaling pathways, but it also includes the genetics. It's actually modifying the genes of the body through epigenetic changes and anti-mutation effects on the body. So it has a vast array of different connections that are unparalleled in the story about signaling molecules for the body. In particular, it's highly effective for inflammation. It's the most superb action of all. In that, in this particular slide on the right, I tell you that the toll-like receptor 4 is a key factor in causing inflammation, generalized inflammation of the body. And by activating or inhibiting this particular receptor, or excuse me, activating this receptor leads to activation of the microglia in the brain, and it causes inflammatory signaling, and that occurs in the M1 type of activated macrophage occurs all over the body, and it can be stimulated by the TLR4 receptor. Whereas beta-caryophyllene actually reverses that, switches it over to a healing profile of the M1, M2 type. So it's going to rectify a lot of the inflammatory markers that I've got listed there immediately and if highly effectively with incredible results. And I've got the articles that support this particular mechanism on the left, and I go down through those, including the nuclear factor kappa beta, which activates and enhances the receptors for high glucose and induced mesenchymal cells. So these inflammatory cells in the kidney are actually protected by beta-caryophyllene in this particular way. So inflammation-wise, this is a composite slide where beta-caryophyllene is affecting the heart inflammation, the brain, the gut, and the airways of the body. It first acts on the on the CB2 receptors, and the CB2 receptors work over here on the other endocannabinoid substances, increasing their levels of PEA and OEA, which are actually endocannabinoid stimulators and receptor binders to the PPAR alpha there on the left. And then the CB2 receptor actually blocks inflammatory signals. It also activates the PPAR gamma receptor, which is a nuclear receptor system that has amazing impact on the body, actually generating different RNA and different protein molecules that have major effects on the body's metabolism as well as inflammation. Now, it blocks the neurotrophic factor kappa beta, and which stimulates all of the cytokines that form inflammatory mucus, inflammatory signaling at all throughout the body. And it actually works on the vascular inflammation, preventing the vascular inflammatory signaling and invoking vascular relaxation as well. Now, the main target for beta-caryophyllene is at the CB2 signaling receptor, and this particular target is found on every one of our immune cells, which is why it can be so effective as an anti-inflammatory. It works on macrophages, neutrophils, T cells, dendritic cells, and even mast cells that I want to go into in a moment. And by signaling at the CB2 receptor, it turns off the inflammatory signals completely and regularly for the body. But it shifts it over to a healing phase so that you still protects the body, but you don't lose immunity and immune function. So what are the neurological effects of beta-caryophyllene, the interaction with the endocannabinoid system? Well, first of all, we'll talk about the CB2 receptor in the nervous system. We'll talk about the neurologic pain. We'll talk about beta-caryophyllene and brain health, research, Parkinson's, stroke, and mood and depression. All these are primary targets for beta-caryophyllene, actually. So first off, the CB2 receptor is extensive in the central nervous system. It's got locations in the hippocampus, the cortex, the cerebellum, the thalamus. It's got loaded with connections, but it hasn't been really recognized because of the enormous discussion about the CB1 receptors and the THC effects of cannabis. Whereas the CB2 receptor is where the action is in terms of inflammation, in nerve signaling, in neuritogenesis and neurogenesis. It's all in this action, and it's been generally ignored by most people, and it's not in the current knowledge. So this molecule, this receptor system has huge functionality that affects our mood, affects our neurologic function, and it protects, and it is involved with malignancies, as well as inflammatory conditions like Alzheimer's and Parkinson's. So with regard to neuropathic pain, CB2 receptors actually work in conjunction with the inflammatory angle and the neurogenic angle. So they're blocking inflammatory signals and synaptic functions that are inducing pain, but it's also producing an anti-inflammatory effect by action at the glial cells of the brain. And that leads to resolution, a high resolution of neuropathic pain. And we've seen that in a number of preclinical and preclinical studies. So if CB2 is acting mainly at the CB2 receptor for the activation, it's producing desensitizing mast cells, and it's performing anti-allergic phenomena, anti-pain phenomena. And then the CB2 activation is actually neutralizing microglia and putting it into healing mode. And that's leading to relief of neuropathic pain. Now, it actually engages and blocks neuroinflammation at all levels, and it actually promotes brain-derived neurotrophic factor, which is imperative for proper memory and cognitive function and forming our mood as well. And then on the right, you can see that it engages in Alzheimer's disease, the amyloid beta fibers, and it blocks that particular pathway all the way to preventing and interfering with anti-Alzheimer's effects. The beta-caryophyllene effects on the brain are extensive. Including regulating the endocannabinoid system, it's promoting neurogenesis, so the making up of new neurons and new connections for their new neurons. It's shifting the microglia to the healing type, so it's reducing inflammation. It's restoring the blood-brain barrier from leakage and permeability issues that happen so often for any inflammatory disease. It's regulating proteostasis and autophagy. And proteostasis is a formation of proteins like amyloid beta that need to be destroyed and removed. It's preventing that particular abnormal folding. And it's preventing the tau tangles and the neuron degenerative amyloid beta. It increases mitochondrial formation and function. And I'll get to this a little bit later about its mitochondrial effects on the mitochondria very specifically. So I talk about what is the endocannabinoid dysfunction in Parkinson's disease. Well, first of all, you've got a bidirectional interaction with the dopamine and these active neurotransmitter systems. There's a doubling of the anandamide or the AEA levels in the body. There's compensatory mechanism to alleviate dopamine depletion by excessive production of dopamine from dopamine neurons that leads to their depletion. And it's actually going to downregulate CB1 receptors that are initially and is later going to be upregulated. So and CB2 is upregulated as well. And it's almost as if the CB2 receptor is begging for a connection, begging for a ligand that could happen and take it off and get it into an active phase and restore the wellness of these individuals. So these particular studies have emphasized how beta-caryophyllene can restore people with Parkinson's. It can prevent their cognitive decline. It can prevent their complications as well as the progression of the disease. It actually protects the dopamine neurons from injury, from toxins, as well as from different effects that can naturally occur with Parkinson's progression. Now, it decreases the pain of Parkinson's as well. Parkinson's patients have a great deal of pain, and they also have a lot of dyskinesia or abnormal muscle movements as an effect of one of the medications that they use with L-DOPA. So it actually protects against that. So it's hitting on all targets for the prevention of progression of Parkinson's disease. Now, beta-caryophyllene and cannabidiol can work alone or in combination for ischemia of the brain. And this is one of those studies that I want to bring up that shows you how the benefits of cannabidiol can benefit caryophyllene. Through separate mechanisms, they actually promote and preserve the brain in an ischemic stroke-like model of beta-caryophyllene and CBD. And you see the effects that there seem to be minor, but the combination of the two substances led to a distinctly different penetration and depth of the damage that was caused by the stroke injury. So it can be used together, or it can be used in combination, or it can be used separately alone. And what about anxiety and depression? Now, anxiety and depression is part of a spectrum of illness. It's dealing with stress, and anxiety and depression are all part of that spectrum, and they lead to a number of different pathologies, but they all are related to inflammation. The best evidence we have is a number of different pieces. One in particular was combat training induces stress, and depression and anxiety is accompanied by increased blood-brain barrier permeability and increases in pro-inflammatory mediators. So it has to do with a lot of inflammation. And if you're losing sleep, if you've got an inflammatory or autoimmune disease, then you're going to have increased levels of inflammatory molecules that could lead to depression and anxiety and stressful reactions. Now, the cytokines are elevated in anxiety and depression too. So you've gotten a mixed effect. And whereas beta-caryophyllene has been shown to reduce the anxiety and depression policies, properties of these situations, of the stress on the body. Beta-caryophyllene attenuates neuropathic pain and depressive behaviors in diabetic mice, and it actually acts as an antidepressant like in constraint stress-induced depression. So it has a number of interesting and characteristic properties, but the amazing thing, it works immediately. And one of the areas I want to focus on is the generation of inflammatory condition by obesity and by a high-fat and high-sugar diets. So this study looked at animals that were preferentially fed high-fat and high-sugar diets that developed behavioral alterations, and that is defined as anxiety, depression, and memory deficits. In addition, they developed insulin resistance, and they essentially were on a metabolic syndrome. But beta-caryophyllene used in this process restored activation of the CB2 receptors, and it actually reduced the inflammation, the oxidative stress, and the inflammation of the individual cells. And it restored the brain-derived neurotrophic factor, as well as the stimulation for the PPAR receptors that work on the mitochondria of the body. It actually acted at the CB2 activation. It acted at glucose and insulin receptors. It acted on these oxidative stress molecules and lipid peroxidation. It prevented that particular process. And it activated a number of signaling molecules, in particular the SIRT1, which we'll hear about a little bit more later, and the brain-derived neurotrophic factor as well. So let's talk about longevity. Let's talk about what the optimal aging and the endocannabinoid system looks like. We're going to talk about senescent cells. We're going to talk about sirtuin as a signaling molecule. We're going to talk about cardiovascular health, weight, and DNA molecules, and how beta-caryophyllene can protect against mutagen and protect and actually repair DNA. So what is senility? What is senescent cell? A senescent cell is an excessive accumulation and systemic absorption of these stress-like substances in senescent associated secretory phenotype substances. That's the SASP. And it's spread is a natural process and it needs to go on, but it's turned a protective process and a response into a pathologic mechanism. So it's actually related to a number of age-related diseases, and our entire deterioration as a health in our health span is related to it. So the senescent cells have been identified as the key culprits of organismal aging, and their irreversible cell cycle arrest occurs with these cells. So we'd like to minimize the number of senescent cells, but we'd also like to get rid of them because they actually generate a number of molecules that have derogatory effects on the body, including cytokines and inflammatory substances. Their antioxidants and anti-inflammatory compounds have the potential of being anti-senescent effects. Things like rapamycin, metformin, curcumin, resveratrol, and beta-caryophyllene are modulators of the SASP phenomena. And the epigenetic modifier, like SIRT1, modulates SASP as well. And so if we can activate that particular system, we can get a good response to removing and resolving the senescent cells. So I don't mean to say that the only way that you can correct for the endocannabinoid system is through a drug or a substance. There are many ways of correcting for and improving longevity. It could be exercising, fasting, a ketogenic diet, or a Mediterranean diet. Foods that contain polyphenols and flavonoids and terpenes and nutraceuticals, they all have a measure of activation of the endocannabinoid system and of these particular pathways in the body. So exercise stimulates AMP kinase, the key energy trigger that really senses the nutrient situation and decides whether somebody's going to go through autophagy or not, or they're going to be protected from that. There's nutrient deprivation actually stimulates some of these effects. And so it works at the SIRT, but it also works at the PGC1A, which is a stimulus for mitochondrial genes to perform greater function, not only greater in terms of greater numbers, biogenesis, but also in the metabolism and the electron transfer of these particular molecules. So if we can take action like exercise or like nutrient deprivation, then we can stimulate these particular receptors. And that's what beta-caryophyllene can do. In the cardiovascular effects, the reason that the highest death rate in the country is related to cardiovascular disease, and beta-caryophyllene has been shown to have a protective agent against myocardial injury, against epithelial damage in the first step in defining atherosclerosis and endocardial disease. It's reduced atherosclerotic atherogenic index and coronary risk reflex. And it's also actually reduced hypercholesterolemia. It inhibits the endothelial dysfunction that leads to myocardial infarction, and it reduces the pericardial inflammation and acute pericarditis. Actually attenuated against cardiotoxicity and heart failure in chemotherapy-induced through CB2 receptors. So it's got an amazing property, and it's highly protective in the cardiovascular system as well as the neurologic system. And in the vascular system, it has amazing properties as well, where it actually inhibits the leakage of these membranes, and it prevents the migration of LDL particles underneath the cellular tissue. It prevents the foam cell. It prevents termination, which could be key and important for atherosclerosis, and it blocks the inflammatory signals of the body. It's blocking the reactive oxygen species, and it actually blocks oxidative LDL formation as well by its prevention of the fat metabolism in abnormal fat oxidation in the body and in the vascular tissue as well. Now, down at the bottom, you've got the effects of a high-fat diet creating insulin resistance, dyslipidemia, where you've got the reverse effects of beta-caryophyllene, where it blocks those particular adverse effects entirely through PPAR receptors and going through the CB2 receptors. So it has an incredible potential for treating many different diseases, vascular diseases, as well as heart disease. And I want to point out that beta-caryophyllene was studied in comparison with a GLP-1 agonist in 76 mice in 6 groups. They compared weight loss, fat distribution, and signaling molecules. And of course, we know that weight is a particular potential, excessive weight and obesity is a particular potential for causing inflammation and inhibiting our life potential. And so if we can correct for obesity, this would be a marvelous prevention, and systemic metabolic disease could be fabulous. And beta-caryophyllene actually corrected for much of the metabolic disease and the obesity for these particular mice. It had superior fat weight reduction in the mice that were used. It improved adipocyte hyperplasia and steatosis. It improved dyslipidemia and cholesterol pathways. It reversed the clock genes in the liver that control weight gain as another sensitizer to metabolism. And it activated a number of other receptors that were very positive in creating energy and expending much of the accumulated fat that has been stored in the body through metabolic processes. On the right, you see the image of the effects of after 4 weeks of beta-caryophyllene. These rats lost 10% of their body weight, and that was all fat. There was no muscle lost at all, and this particular study was repeated over and compared to another GLP-1 that actually achieved the same results after 8 weeks of study that the beta-caryophyllene achieved at 4 weeks of therapy. So I think this is one of the most profound protective slides that I've got, where beta-caryophyllene actually protects against as genoprotectors, protecting the genes. It's inhibiting the mutation, mutagen bioactivation. It's inhibiting the uptake of mutagen formation in the cells, and it's repairing mutagen-induced DNA damage. So this has a profound effect on the longevity. So if taken over time, beta-caryophyllene could correct for many genetic issues, at least minor genetic and epigenetic formations from mutagenesis. And in fact, cancer cells often are faced with a number of mutations within the same cancer victim, and these beta-caryophyllene could actually prevent that sort of the DNA modification and target those particular cells very effectively against destruction. So what are the metabolic functions? What are the metabolic functions of beta-caryophyllene? Well, first off, it's working on the PPAR systems, the peroxisome proliferator active receptors of alpha and gamma. And it's working on both receptors, not just one. It's working on the mitochondria. It's actually mimicking fasting. And the research has been extensive in this area. It has metabolic effects on the mitochondria, on the body, diabetes, endocrine system, microbiome. It's hitting all the targets of longevity, actually. So what are the PPAR nuclear transcription factors? Well, they are an enormous potential for modification of the body's metabolism and the immune function. And they work by targeting, and they're working on as a nuclear receptor, creating particular proteins and RNA molecules that deal with metabolism and immunity. And they're very valuable. And you can change these by diet, and adipose tissue can change it. And you can also change it by different substances when on intake with food factors and nutraceuticals. But the PPAR and the PPAR gamma are connected to this mitochondrial function in a vast and extensive way. And I think that these are the key targets of beta-caryophyllene, in that it's active against both receptors, and you're going to get the best of both worlds. Now, I look at WAT, which is white adipose tissue, and you get BAT, brown adipose tissue. The difference is that brown is thermogenic, and it's going to create a lot of heat energy through uncoupling proteins in the mitochondria. So it's actually beta-caryophyllene is going to stimulate the PPAR alpha, and it's going to stimulate this particular effect, performing more brown adipose tissue. And it has vast effects on insulin secretion, glucose metabolism across the body. It actually has ketogenic effects in storing, and it actually has some benefits in lipid storage, where there's a reduction in gluconeogenesis within the liver as a result of PPAR signaling. So this is an important role that beta-caryophyllene offers for attacking and signaling both these receptors in a very positive way. So fasting and energy stress can actually induce the AMP kinase, and that's going to activate a number of different receptor systems, including mTOR, which has a lot to do with autophagy. And it's going to actually stimulate PPAR alpha as well, that leads to fatty acid oxidation and ketogenesis. And it's going to stimulate the FGF factor 21, which is associated with lipolysis. So it's going to release the fat molecules from the fat cells so that it can be metabolized. And it's going to prevent gluconeogenesis by its combination of effects. It has a marvelous effect on the ketogenics and fasting and the PPAR alpha. So it could offer some major benefits in this area. In fact, what I've seen is the beta-caryophyllene mimics fasting for the most part. And because fasting is designed to generate ketone bodies, and ketone bodies actually have a therapeutic response in the body. They represent a signaling molecule as well as a metabolite for different metabolisms of the mitochondria, very specifically. It also signals the mitochondria. And beta-caryophyllene signals has all of the same metrics for benefits that ketones and fasting do. It suppresses appetite. It activates the nuclear receptors of PPAR gamma and PPAR alpha. It promotes uncoupling protein, which is a protein that actually burns and produces heat in the body rather than producing energy or creating reactive oxygen species. It stimulates glycogen like protein 1 or GLP-1, and it actually stimulates adiponectin, which reduces appetite considerations. It promotes mitochondrial biogenesis, making more mitochondria so they can burn more energy. And it's actually inducing an energy expenditure through the activation of this PGC1A receptor signaling molecule. It decreases oxidation. So in spite of that increase in the mitochondrial function, it actually has an antioxidant effect that reduces the ill effects of reactive oxygen species and preventing all of the complications that are related to it. And it decreases the glycolytic flux, and it controls insulin and the potassium channels, and it actually regulates insulin receptors very specifically. It decreases the neurologic excitement and glutamate and GABA ratios. It suppresses inflammation as well. So all of these changes, including changes in the gut microbiome, where this particular bacteria that is associated with a ketogenic diet is actually promoted by beta-caryophyllene and by a ketogenic pathway. And it's going to upregulate autophagy pathways for longevity in these particular genes that are listed below. Now, this is in contrast with the use of sucrose and glucose and on the peripheral and central appetite signals. This particular study showed that rats who had elevated levels of free fatty acids, triglycerides, and cholesterol with the increment of sucrose on their diet. It increased the ghrelin, leptin, and decreased the PYY, which is a molecule that has to do with appetite suppression, and it downregulated the hypothalamic mechanisms that are also involved with appetite. But it upregulated the hypothalamic CB1 receptor, the mRNA. So the CB1 receptor was upregulated, and that led to the correlation that obesity has with activation of the CB1 receptor system. So by using highly processed foods with sugar in them, you can actually change the way the body works and activate the endocannabinoid system in a negative way for dysfunction. Beta-caryophyllene also regulates metabolism. By regulating the GLP-1 and adiponectin, it's actually changing the way the body works metabolically. It increases the mitochondria, but it decreases reactive oxygen species, and it corrects for the uncoupling protein. We talked about that a moment ago. The increased energy expenditure leads to weight loss very significantly and brown fat. comes from white fat. So you're getting a browning of the fat in a marvelous way, and you're getting effects on the lungs and the brain in a very positive way for the body and on adipose tissue. You're actually preventing the hypertrophy of white fat in the body. And then it also regulates appetite. Now, you know that GLP-1 has a major appetite suppressant, but that is the factor that beta-caryophyllene has, one of the factors for decreasing appetite, because it also reduces food intake by the inflammatory connection. And there are other receptor signals that are increasing appetite, and it regulates those as well. And the shifting from the macrophage to the M1 to the M2 is in response to adipose tissue as well. And that particular effect reduces inflammation. So you're getting many mechanisms that are involved in the appetite suppression, along with hormone effects as well. So within the hormone effects of the body, we've got adipose tissue, melanocortin, leptin, adiponectin, mitochondria, nuclear receptors, insulin, and GLP. And these all have effect on the fat tissue. Now, we think of the fat tissue as being a leftover and a neutral area, but in fact, that's an organ system that produces quite a bit of inflammation when it's excessive. When those cells have expanded beyond their normal size, they can produce quite a bit of inflammatory substances, and they instill steroid conversion as well that leads to some catecholamines and some steroid effects as well. Now, with regard to diabetes, it's incredible that this substance actually increases the glucose uptake on controlled glycemia by activating and increasing the number of GLUT4 insulin and glucose receptor cells in muscle. So the muscle cells are absorbing more glucose, whereas they're actually burning more in their metabolism processes on the mitochondria, where it actually prevents oxidation and stress inflammation on the pancreas. And that could mean that we could preserve insulin production for quite a bit longer in CB2 in diabetic type of patients. Whereas it actually increases insulin secretions and is controlling blood glucose levels, but it's reducing the glucose absorption from the small intestines as well, and it's preventing the lipid storage in the liver, the visceral fat combination that leads to steatosis and fatty liver disease. And all of this is going to be controlling blood glucose levels to an enormous degree. Now, for weight loss, this has a huge potential in that it actually decreases food cravings, it improves energy output, it decreases visceral fat in the body, and it increases fat breakdown. So you're releasing more fat, it's bringing more of it is being burned in the mitochondria, and it reduces the mitochondrial dysfunction as well. And it's modulating those hormones. So with respect to the gut, caryophyllene has a therapeutic alternative for intestinal barrier dysfunction caused by obesity and irritable bowel syndrome. So you have the different effects of the cannabinoid system and beta-caryophyllene on the goblet cells that produce more mucus, on the membrane, the lining of the gut, and preventing the weak permeability and the leaky gut phenomenon, and on the inflammatory level that affects the inflammatory cells, the IL-17 type of cells that actually detect for incoming sensitivities and proteins and bacteria that could cause any problems and create a reaction and inflammation in the gut. It calms all of that in particular. And so it's also changing the microbiota to a more healthy balance of cells. So it's got huge different properties on the gut as well as the rest of the body, and particularly levels of protecting it from endotoxic levels of substances that can accumulate from abnormal microbiome. So I want to summarize here that the endocannabinoid system is the master regulator of the body. And CBD and beta-caryophyllene both work on this particular system. But you may have run into barriers with CBD because, well, that's about it for my presentation. I wanted to tell you that this is an extraordinarily valuable substance, and We're looking at restoring, at Blair Medical Group, we're looking at restoring the endocannabinoid health for everybody, creating balance and complementing health through this modulation of this vast and important and primary master controller of the body system.